People, not things. That's the slogan for the paradigm shift in game design. Because you see, games are about things. They are not about people. Oh, sure, there are, of course, plenty of pictures of people in games, and they're very nice pictures of people, but they are only pictures. The people may look like people, but they don't act like people. When you actually try to interact with them, basically, they're very stupid. And that's what's wrong. That is, can you imagine art without any people in it? How about movies? Can you imagine what a movie would be like if there weren't any actually working people in it? How about books? What if you had novels that didn't have any people in them? You know, that just wouldn't be any good, would it? So what makes these things interesting are the relationships among all of the people. And so that's what we really had to focus on, getting the relationships among people, getting that to work. How are we going to do that? How are we going to write programs that somehow operate with the relationships among people? Well, at this point, we had to change to a new line of thinking completely. And I would like to introduce you to something that I modestly call Crawford's first law of software design. And that is, whenever you're designing a piece of software, the very first question you ask, and the question you ask over and over and over, is, what does the user do? Not what does he see, not what does he hear. It's not interceivity, it's not interhearivity, it's interactivity. It's about action, about doing things. That's what's crucial. And so what you ask more specifically is, what are the verbs that you make available to the player? That is, what can the player do? But by thinking in terms of verbs, the design process becomes much more clear, because the way you design a game is to write the verb list. This is where you start, by creating the list of verbs that you're going to give to the player. You don't need storyboards or anything like that. Storyboards are for movies. A verb list is what you use for games. And to show you how powerful the verb list is, let me show you two verb lists. These are partial verb lists. Here's one. Here's some of the verbs from one game. You can immediately see what this game is about. You can immediately see what happens, what the player does, and how the game is going to work. All just by looking at 6 verbs in the verb list. Here's another verb list. Can you imagine a game using this verb list? Wouldn't that be an interesting game? In fact, wouldn't it be a fantastic game? Of course, how would we do such a game? For example, how would we handle the input for such a game? Well, it's easy with the first verb list. To turn left, you push the thumbstick to the left. To turn right, you push the thumbstick to the right. To duck, you push it down. To run, you push it forward. It's all very simple and obvious how to handle the input. But how would you do the input for verbs like this? It doesn't make any sense. There's no easy way to figure out how to connect the input to the verbs. Or how do you calculate the consequences of the actions? In other words, when the user does something, you want to calculate what happens. It's easy with the first verb list. There's some very simple calculations you have to do, and that's all you need to do to figure out what happens when the player does something. But how do you figure out the consequences of this? If somebody says, I love you, what should happen? How would you calculate what should happen? This is a much more difficult problem. Let me summarize now the 5 dragons that we must slay if we're going to get people into our games. The first dragon is language, because we have to be able to get language working. After all, language is the primary way that people interact. And so if you want to have people interacting, you got to have language. That's just the way it is. So we need to put language into a computer. Now, to do that, we have to take into account a very important fact about language. Language mirrors reality. Language reflects the reality that we live in. For example, somebody who lives in the Arctic regions where it's cold and snowy all the time, that person lives in a reality with lots of snow and ice. And so that person's language will have all sorts of different ways to talk about different types of snow or ice. On the other hand, a person who lives in the desert where there's never any snow or ice, that person's language has no words, no ways at all to talk about snow or ice, because language reflects the reality in which we live. So if we're going to put language into a computer, that means we have to put reality into the computer as well. And that's a problem because, reality is kind of big. How would you define reality in programming terms? It's impossible. You can't do it. But there is a solution, and that is to make a toy language with a toy reality. After all, the games we make are not real. They are toy realities in which only a limited amount of stuff is real. And so if you're going to have a toy reality, you should be able to make a toy language. Unfortunately, the reality of people, of social interactions, is vastly greater than the realities we have in games. Games are very simple. Real people are very complicated. So this is not going to be an easy problem. We're still going to have to solve some extremely complicated problems getting a working language, toy language, onto the computer. As it happens, I solved that problem some years ago. I've created something I call Dicto. Dicto is a system for creating languages that you can use inside a game. Here's an example of it operating. And what's important about Dicto is that you create the language at the same time you create the reality. It doesn't work to say, well, let's create the reality and then a language to go along with it. And you don't say, well, let's create a language and then a reality that fits it. You have to create them both together. So when you create a word, you have to define how the word works, what kind of calculations you make on the word. And this can be very difficult, very complicated. But by creating the word and the reality together, that's how you can make this work. Another variation on Dicto, another version, doesn't use words, it uses little icons. And that's what I am doing with Siboot. I'm using a language that has icons in it. So the idea here is if you're going to have language and reality, you've got to put them together. They've got to both be there simultaneously. And that's what makes it so difficult. I have also created, for example, this is what my system does. This is how you define the words in the dicto system. You define them with little scripts that specify exactly how each part of a sentence functions, how it operates. This is a lot of work, but it can be done. The next big problem we face, the next dragon we have to slay, is personality modeling. We have to create a model for personalities. Now, that really isn't that new of an idea. In regular games, we use models all the time. For example, we have a model for a gun. That's a set of numbers that tell us how the gun acts, how it performs in the game, what it can do. And that model is what we use inside the game to calculate what happens. Well, as it happens, we've had a personality model since the 1970s. Dungeons and Dragons, that old role-playing game, had 6 personality traits for each of the characters: strength, constitution, dexterity, intelligence, wisdom, charisma. Those were the things, but those weren't about personality. They didn't tell you what kind of a person it is. They just told you what he could do in a dungeon. What we need is a personality model that talks about people's characters, about what drives them emotionally. So we need something like this that would tell us how good a person is, or how honest they are, how dominating they are. And so we need a different kind of personality model. As it happens, this is the personality model that, after years of work, I've settled on this as the best overall personality model. The importance of a personality model is not just that it gives you numbers. It gives you numbers that you can use. In other words, you can use the numbers in the model to calculate what a character will do in any given situation. That's what you need a model for. The next big dragon to slay is to have faces with emotions on them. And here, games people are close but not quite right. And the example I give is provided by 2 movies that came out more than 10 years ago at about the same time. The first movie was Final Fantasy. It was made by a games designer, and to him it was very important that the faces be real. And so they went to all sorts of trouble making very realistic faces. The second movie was Shrek, and the faces in Shrek are not realistic at all. They're caricatures, they're cartoon faces. But the difference is that the faces in Final Fantasy have no emotion. They are cold, they are boring. Whereas the faces in Shrek have lots of emotion to them. They have feeling. With Final Fantasy, they tried to get photorealism, and they got it. But with Shrek, they tried to get emotional realism. And there's a huge difference between emotional realism and photorealism. And that's why most of the games products, when games people try to create faces and such, they end up getting very boring faces. The people in Hollywood know how important it is to have faces with feelings in them. It doesn't matter if it's not very realistic or how many hairs there are in the eyebrow. What matters is the emotion that is displayed. And that's something I've been working on for years. Here's gives you a very brief idea of some of the technology, version of the technology we're using now. This allows an artist to put emotions onto faces, emotions that are big and bright and loud, not subtle at all, because that's what we need at this stage. The next dragon to slay is a narrative engine. That's the software that calculates how the story progresses. This is very complicated software. It has to figure out what people are doing and how they're doing it and how the reactions to events should proceed. Very complicated stuff. Here's some of the software that is part of my engine, but there are pages and pages and pages because I have a narrative engine. It's huge and very complicated and, well, what can I say? The last dragon to slay is the necessity of an IDE, an integrated development environment, the programming environment you use. Now, programmers use this all the time. It's got a text editor for writing the program code. It's got resource managers, ways to bring in sound and music and images and video and pull it all together into one piece and then run it, debuggers, all sorts of things to test the software. We need something like that that works with people software, that would work with a narrative engine. And once again, yep, I built something like that. It's called SWAT. We built it, 6 years ago. And here's an example of a typical screen in SWAT where you design the various elements or components of a story. This is defining a word. Okay, so I created all of this wonderful technology, and in fact, if you'd like to know more about it, you can go to this website, storytron.com, and it'll tell you all about this technology. And you might be wondering, well, gee, if I made all this wonderful, beautiful software, why haven't I conquered the world? Why am I not filthy, stinking rich and famous and so forth? And the answer is that the Storytron technology is too complicated. There are a million buttons to push and dials to turn and levers to pull. It's just, to understand it, it takes an enormous amount of work, and to actually use it, well, even I had real difficulties pulling all the pieces together to build something that actually worked. And so, as a result of this, Storytron was a failure. It just didn't work. And therefore, out of the way, Kitty, I've spent years thinking about this and what to do about it, and I've decided that the most important thing to do is to simplify the technology. So I've spent the last 7 months or so ripping the technology apart, stripping out places. It's like I'm a surgeon with a cleaver, just chopping away at the technology, throwing out portions, simplifying it enormously. The end result is nowhere near as powerful as the earlier system, but it's easier to understand, and that's what's important. And we are now trying this out. I'm developing all of this in a new game called Siboot. And this is a screenshot from the game. And you can click on the icons in the lower, along the bottom edge, and it does things. When Siboot is completed, I'll put it out there for people to play with. And maybe they'll say, oh, wow, this is wonderful, this is fabulous, you solved the problem, hooray, hurrah. Or maybe they'll say, it stinks, it's awful. I don't know, we'll just have to wait and see. But one thing I do know, I've been following interactive storytelling now for 20 years, more than 20 years. And really, I started more than 20 years ago. Other people didn't get interested into it until about maybe 15 years ago. And they didn't get serious about it until about 10 years ago. And there was a lot of activity, all sorts of ideas. And I've gone to the conferences and I followed all the activity on the web. And there was a lot of excitement. But in the last 5 years, well, the excitement is gone. Interactive storytelling has slowed down a lot. It has lost its energy. There are no new ideas coming out. I'm monitoring it closely, and I have not seen a new idea in the field in 5 years. Moreover, many of the people in the field are leaving it, going off to do something else, because they've learned that it's just too difficult, that they can't get it working. And so they're giving up. And so it looks as if interactive storytelling, that is, games about people, not things, well, it looks like it doesn't work, and we can't get it working. And so I've decided to give it one last shot. I'm going to open up the source for my technology. I'm going to make it publicly available and offer it to the world as a platform that people can use to make interactive storytelling or games with people in them. Storytron technology will be out there and people will be working with it, and maybe it will get interactive storytelling working again. Stay tuned. If you're interested in following this project, just follow my website, erasmataz.com.